All right, guys, we're going to evaluate some logarithms. The first part of chapter 7.4, the first part of it, evaluate logarithms. Let's see how it goes here. Definition of a log, first of all, is this right here. When you see a log, let me get my marker ready. Okay. Log, the way you'd read this right here, I'm underlining, is log base b of y equals x. And all that means is you take b, raise it to the x power, and it's got to equal y. It kind of makes a circle. B to the x equals y. It's written right here. That's what makes it true. You read it like this, log base b of y. And what it means is it's true only if b to the x power is y. And a lot of times you're going to have to figure out what the x is over here. It's a method for finding exponents. This is the inverse of doing an exponent. A method we use in math to find exponents when we don't know them. All right, rewrite each one in exponential form. Again, the pattern is this. You take the base. This first one is base. Let me make it a little bit bigger here. The first one has base 2. So you would say 2 to the third power equals 8. So that's the pattern. 2 to the third power is 8. The second one, 4 to the 0 power is 1. Notice all these are true. 112 to the first power is 112. And the last one, 1/4 to the negative 1 power. Don't forget what a negative 1 power does. A negative 1 power flips things, so it would be 4. All right, so I hope you understand the pattern there. Just 112 to the first, 112, 4 to 0, 1. Okay, the same pattern over and over again. That's how you work out a log. All right, evaluate here. Give you something just to evaluate. Again, I'll make it just a tad bit bigger here. And what they're asking you here on part A is, okay, 4 to what power is 64? That's what it's asking you. It's really doing this kind of thing. 4 to what power is 64? You should know that in your head. It's the third power, so the answer is just 3. On part B, it's asking you 5 to what power is 0.2. Now, don't forget this. 5 to some power is 0.2, but 0.2 is really 1/5, which means they just flipped it, so it's just negative 1. Negative 1, there we go. The next one is asking you 1/5 to some power is 125. That's what it's asking you. And so all you got to do to work that out is figure out, first of all, this side's a fraction. So what I'm going to do to make it a little bit simpler is go ahead and flip this one, which means the exponent is negative. So what power would you raise 5 to get 125? And I think you know it would be the negative third power, so negative 3 right there. And the last one, part D, it's asking you 36 to what power is 6. What would you do to 36 to get 6? Well, you take the square root of it. And we just did fraction exponents not long ago. Don't forget, fraction exponents, bottom is the root, top is the power, bottom is the root, top is the power. So the square root of 36 is 6, which means it's the 1/2 power, or 1/2. So when you evaluate the logs, it's asking you what power do you get? What power would you raise it to get the other number there? Okay, special logs. One's called a common log. A common log is a base 10. Your calculator does base 10. And what's going to happen, you're going to see base 10. They won't write the base 10 very often. They'll just write log x. If you just see log without a base, log, that means it's base 10 automatically. And another type is called a natural log, which is base e. And we've seen e already. So if you just see this, if you see ln, which stands for natural log, and there's no base written with it, and there never will be, it's base e. So base 10, log, common log, natural log is base e. And your calculator has buttons that'll work that out for you. If you have your calculator with you right now, if you look down your left-hand column, there's a button that says log. If you just hit log or log 8 in your calculator, it's going to come up and tell you 0.9031. And that's it. We usually do go 4 decimal places with logs. And right below the log button is an ln button. You can hit ln 0.3, and you get negative 1.203040. And you might want to punch those in to make sure you get the same thing I got, to make sure you did it correctly, make sure you know where the buttons are. And the reason this one is negative is because remember e is like 2 point, that's e right there, base e, and it's asking you e to what power is 0.3. Remember e is 2.71828, so it's taking a number, making it smaller, which means you're having to flip it. That's why the exponent is negative there, or the answer is negative. All right, evaluate these. Use calculator if necessary. Don't use a calculator if it's not necessary. So both ways. So the first one's asking me 2 to what power is 32? Well, 2 to the 5th power is 32. Don't need a calculator for that one. Second one, 27 to what power is 3? Here's what I know about 27 and 3. I know 3 is the cube root of 27, and And the way you do an exponent for cube root is the 1/3 power. Remember, bottom is the root, top is the power. Okay, number 7 here says log 12. Notice there's no base written there, it's just log 12. So I'm going to take my calculator, hit log 12, it's base 10. I'm going 1 point, that's not an 8. My poor eyes, I'm getting so old. 1.0792. The last one says natural log of 0.75. Just take your calculator, natural log 0.75. You get negative 0.2877. You know why it's negative? Because it is smaller than 2.71828. And the last thing here, inverse properties. Inverse properties for logs do this right here, and these are big. If you have log base b of b to the x power, it's just x, meaning this. Log base 3 of 3 to the 5th. Think about what that's asking you. That's asking you 3 to what power is 3 to the 5th? One more time. 3 to what power is 3 to the 5th? 5 is. And that's what that property is saying. If the big number here is the same as the base, whatever your exponent is, that's your answer. Should be pretty easy there. And the backwards of that is also true. If you have a log in your exponent and the base in your exponent is the same as the base down here, the answer is just what x is. So if you see something like this, let's say you see 4 log base 4, 2. The answer is going to be 2 because these are inverses of each. Remember, log is the inverse of an exponent. That's what's the inverse property. Okay, so it says simplify here. This is one of each of these. Now the first one says 10 log 4. Now, if the log 4 in the exponent doesn't have a base, which means it is base 10, and because you have base 10 here and base 10 up there, it's just 4. And that's all they're ever going to give you, by the way. The second one is saying 5 to some power is, now this one, think about this. This is really, I need to erase that. That 25 is really 5 squared, and there's an x there. So it's really 5 to the 2x power. Again, here's our inverse property. I have the same base there, same base there. The answer is just 2x, because it's asking you 5 to what power is 5 to the 2x power? 2x. One more slide. All right, let's find the inverse of each of these. The first one says y equals 6 to the x power. Don't forget how we do this. We take the x and y, we switch them. This next step's going to look a little weird once you learn from it anyway. Not that big a deal. To get the y, to get the exponent, the only way to find an exponent that you're missing is to use a log, which is what we're doing today. So watch what I'm going to do here. Because the base is 6, I'm going to take each side and do log base 6 of that side. Watch what happens here when I do that. Remember, I'm trying to get the y by itself. Look at the right-hand side when I do that. When I look at the right-hand side, the bases are the same. Log base 6, 6 to the y power. It's asking you 6 to what power is 6 to the y power? Y. We just did that on the last slide. So here's what y equals. Log base 6x. Okay. The inverse of an exponent is a log. Just got it. Just showed it to you. Okay. The last one here, do the same thing. Put the x over here. I'm going to put the y on this side. And when I have a log already, the opposite of a log is an exponent. So I'm going to work this out. Don't forget the base here. The base is an e. So I'm going to do this little e right here. E to the x power is going to equal that. The same thing we started with today. So it's going to be e to the x equals y plus 3. And to get the y by itself, I'm just going to move the 3 to the other side. Just like that. And there's my inverse. All right. That's, to be honest with you, that last slide, maybe like one day ahead of where we are. But that's good. It's good for you to see it. And we're going to do a couple of those in class tomorrow. And I'll see you then.